Hello everyone. Today we are going to do the last exercise for this year, that is 9.6. That's transition with restocking and culling. So it is for doing this exercise, you need to understand 9.5 first. So what are transition diagrams? What are transition matrices? So transition matrices we can use to predict a situation, right? So as you can see here in 9.6, we are going to use the transition matrix with restocking and culling. Restocking means if you are adding something down the track, culling is when we are removing something. So adding something to a transition situation is called restocking, and taking something away is culling. So instead of keeping, like we used to do the examples where the number of trucks at the beginning, the initial transition state matrix like stays the same, and then we continue doing the problems according to that. But in here, the initial situation may change during the year. So that's where if we are adding things, we say it's restocking, and when we are cutting things, we are deleting, removing things, it's culling. So we still use the same formula if you remember from the last exercise. It's initial state matrix, so one matrix to start with, and then for the next state we use transition matrix times the initial matrix, but the difference is we are adding plus B. So B would be a column matrix. It could represent the restocking when we are adding some things to it. And also culling wherever. So when using the restocking and culling recurrence relation, there is no simple rule like we used to do 3 raised to the power 6 and find the answer. Unfortunately, we cannot do that. We need to do step by step by using the recurrence relation. So let's do the example to make sense of it. So the worked example from your book: a company wishes to start a commercial whiting breed farm, and it starts with 20,000 whiting eggs, 4,000 baby whiting, and 500 adult. The following could happen in a year. So now here, what can happen during the year? So they are representing eggs with E, could die with D, and then, or they could live and become baby whiting with B here. So, and then the baby whiting could die, or they could live and become adult whiting A. For adults, they're using A. So they have represented that situation, which is given in the question in the form of matrix here already. So from one year to the next, the situation can be represented by using a transition matrix like this. Okay. So then the company removes 500 adult whitings each year to sell to restaurants, adds an extra 200 baby whiting each year, and estimates that 8,000 extra egg will be laid by the adult whiting during each year. So now they have given us a new situation. You can see something is getting removed, something is getting added. So that's where restocking and culling comes into place. So they have given us the initial state matrix in here, the starting of the question, that is your initial state matrix. And this is your transition. So as it involves the restocking and culling, we need to add or remove something. So we use that formula here. So in first part, we need to find B. So the B is the baby whiting. So how many baby whitings will be there? So what we need to do, we just need to do the simple thing. If we go to the next page here. So we just need to use the information about what is added and taken away. So B would be, as you can see in part over here. So we are just adding that information there. So for 500 adults, so for A, we are putting, it's taken away. So we are just putting a minus sign there, as you can see in here. So we're putting minus 500, 200 are added, then 8,000s are added or total, and then nothing is being going away. So that's your 0 for your D for dying. No one is dying, nothing is given here. So we are putting that 0. So basically we are making a column matrix for this information for part A. Okay. So 500 taken away, 200 added, 8,000 extra added, and then nothing is dying. So we are representing that by 0 over here. So that is the answer for A. Then for B, we need to find the number of adult whitings after 1 year. So that A is the adult whiting. So after 1 year, so you know the initial transition state matrix is already given to you. So what you need to do, you need to use that one and then add this situation, because you know this is what's happening during the year. So that's your B in the formula, TSN plus B. So that is a column matrix. So you use your transition matrix given in the question in the beginning, then SN, which is given your initial transition matrix here, plus adding the new situation. So once you do that in your CAS calculator, you get the answer this. So you know for the adult, that was this one, 1200. So you can see from the matrix the answer. There are 1200 adult whitings after the first year. So then they have asked you, after that, they have asked you to find the number of adult whitings after 2 years. So the same thing, we have already found after 1 year. We are using that matrix which we have found. This one now, so this one is a new one. So instead of the transition matrix T1, S0, this one, we are using now that one. And the same transition matrix here, and using the previous year S1 here, plus because the situation is adding or deleting things every year. So we use the same changed matrix which we found in A here. And then add all of them together and do the maths on the CAS calculator, and you get the answer. So there were 2390 adult whitings after the second year, it's just here in the answer. Okay, then you need to find out, instead of removing just 500 adult whiting after the second year, the company decides to remove enough so that the number of adult whiting remains the same as it was at the very start. So how many do they remove? So it's just basically simple. So there are 2390 now, and initial they have just started to remove 500, so you just take that away. So 1890 adult whitings after the second year. Okay, and then part E. So in part E you need to find, so the company decides to start another farm under exactly the same circumstances, but with one change. The breeder realized that the number of eggs laid by the adult whiting during each year depends on how many female adult whitings they had each year. So they come up with the following modified recurrence relation, where they estimate 50% of the adult, that is the females, each lay 200 eggs a year. So now they have given you a new situation here, a new transition matrix here. So how many eggs will there be after the first year using this model? So you know your initial transition matrix was this one. So you use that one here, times SN, which is your initial, which is this, and then add all the rest to it. So you can see here. So that was initial state matrix and the original transition matrix. You just times that plus whatever is given to you now, and then you get the answer. So there will be 50,000 eggs after the first year. So remember to use that formula, which was this one. Remember that. Sometimes they may give you the how many are adding or removing and the transition matrix, and you need to find this one. Sometimes they ask you to find this one. So you can rearrange the equation to do that. All right, so do the prep question and the exam practice, and we are done with chapter 9. I know chapter 9 is a bit confusing, a bit harder than chapter 8, and we will be doing some revision on Friday, and you will be having your SNN task on Monday. So it could be a Google form, it could be as a Google Doc, or it could be a Edrolo topic test. So I will let you know, and we'll do some revision on Friday. So let me know if you're struggling with any particular concept. I can see most of you are struggling with chapter 9. I'll try to record some video for the revision of chapter 9 if I could. Or otherwise you can just tell me or come on Google Meet on Friday. And tomorrow, today, like Wednesday, I won't be available on Google Meet because I'm on a professional development session today all day. So just email me if you have any questions and complete your work. Thank you. Bye.